Welcome to aminacademy.com. In physics, regarding oscillations, let us do some solving problem. The following figures corresponds to two circular motions. The radius of the circle, the period of revolution, the initial position, and the sense of revolution, that is clockwise or anti-clockwise, are indicated in each figure. Look at this first SHM, that time period is 2s, radius is 3 centimeter, and starting point is here. Now here second case, radius is 2 meter, time period 4 second, starting point is P here. Now we have to obtain the corresponding simple harmonic motions of X projection of the radius vector of the revolving particle P in each case. Take the first case, look at here. Now this some initial point from here, then OA is the radius and AM is perpendicular to the x-axis. Now in triangle OAM, now OM by opposite OM by OA is sine theta. Now OM by OA is this minus x over 3 because radius is 3 is equal sine theta. Sine theta can be written as omega t, therefore minus x by 3 equal to sine omega t. Then sine omega is written as sine 2 pi by t, that is omega equal to 2 pi by t here in general. Omega equal to 2 pi over time period. Then you substitute 2 pi by t into t. Then by cross multiplying and simplifying, we can get x equal minus 3 sine 2 pi by t. Then we want to cut here. Therefore, x equal to minus 3 sine pi t is our SHM equation, which is an equation of SHM, that is x equal to minus 3 sine pi t. Look at the second case here. This is the second case. Radius is 2 meter, time period is 4s, and it's a clockwise direction. Now in here POA equal to theta. This is the second case is here. Look at this is anti-clockwise direction, so we are having t equals 0 starting point, and here in triangle OBN, that is theta is here. Therefore, cos theta equal ON by OB. Therefore, ON equal to OB cos theta. ON equal to minus X equal to 2. OB equal to 2 meter 2 cos omega t. For omega, we can write as 2 pi by t, that is t is time period. Therefore, X equal to minus 2 cos 2 pi by t into t. So, t equal to time period is 4, we substitute. Then x equal minus 2 cos pi by 2 t is, which is the equation of SHM. Let us do next question. A piston, look at here, a piston in the cylinder head of locomotive has a stroke twice the amplitude. Stroke is twice the amplitude of 1 meter. If the piston moves with simple harmonic motion with an angular frequency of 200 revolution per minute, what its maximum speed? Here, stroke of the piston equal 2 times the amplitude. Stroke equal 2 times the amplitude. Therefore, A equal stroke is 1 meter, then divide by 2. 1 by 2 meter. Amplitude is 1 by 2 meter. We had omega equal to 200 rpm. Revolution, omega equal 200 revolution per minute. Then V max is the question. Now velocity maximum omega a, which is equal to 100 into half, equal 100 meter per minute. Velocity of piston is 100 meter per minute, velocity maximum. Then you convert in meter per second is 100 divided by 60 is 5 by 3 equals 1.67 meter per second. Next question. The acceleration due to gravity on the surface of the moon is 1.7 meter per second square. What is the time period of a simple pendulum on the surface of a moon if its time period on the surface of Earth is 3.5 seconds? G on the surface of the Earth is 9.8 meter per second square. Here, G of moon, gravity on the moon is 1.7 meter per second square is given. G of Earth equal 9.8 meter per second square. What is the time period? Time period of the moon is what? We know that time period of Earth is given is 3.5 meter. That is time period is now TE equal formula is 2 pi 1 by GE, and time period of moon is 2 pi root of 1 by GM. Now we divide TM by TE. By simplification, 2 pi cut, and GE by GM. That is, we are dividing TM by TE is square root of GE by GM, which gives TM equals TE root of GE by GM, which gives TE 3.5 into square root of 9.8 by 1.7. Simplification gives 8.4. Seconds. Now We got that time period in moon for the simple pendulum is 8.4 second. Next question. A simple pendulum of length 1, length L and having bob of mass m is suspended in a car. The car is moving the circular track of radius r with a uniform speed v. If the pendulum makes a small oscillation in a radial direction about its equilibrium position, what will be its time period? Here, in this case, the bob of the pendulum is under the action of two accelerations. First one, acceleration due to gravity, g, acting vertically downward, and centripetal acceleration because of the moving round circle, AC is v squared by r, acting along the horizontal direction. Effective acceleration g dash equal to square root of g squared plus AC square. So, therefore, g dash is square root of g square. AC is v squared by 4. Therefore, square of v squared by r is v power 4 by r squared. Now, the time period t dash equal, we know that formula that is 2 pi root of 1 by g, which is equal to 2 pi square root of this L by g is L. L by g is L over substituting g dash is g square root of g square plus v power 4 by r square. This is the expression for time period while the car moving in a circular path as well as the bob is oscillating. Next question. A body describes simple harmonic motion with an amplitude 5 cm and period of 0.2 seconds. Find the acceleration and velocity of the body when the displacement is 5 centimeter, 3 centimeter and 0 centimeter. These three cases. First one, radius r equal to 5 centimeter, that is 0.05 meter. Time period is 0.2 seconds. Omega is 2 pi by t. 2 pi by 0.2 is 10 pi radian per second. Omega equal to radian per second. Now, when displacement is y, then acceleration, we know that a equal minus omega squared y. That velocity v equal to omega into a. That is omega into square root of velocity is the formula is omega square root of r squared minus y squared. In case 1, y equal to 5 centimeter, then 0.05 meter. Therefore, a equal minus 10 pi square into 10 pi square. 10 pi is the omega minus of 10 pi whole square into 0.05 is minus 5 pi square. This meter per second square is acceleration. Velocity is 10 pi into square root of this formula. Omega is 10 pi and r square 0.05 square minus y square is 0.05 square. So it is 0. That is in case when y equal to 0.05, then velocity is 0 at means at the distance of r equal to y, then at the extreme position of circular path, it is 0, that is velocity is 0. Then case B, y equal to 3 centimeter, that is 0.03 meter. So a equal minus, that is minus omega square, that is minus 10 pi whole square into 0.03, simplifying equal to minus 3 pi square meter per second square. Then velocity is 10 pi, that is omega 0.05 whole square minus 0.03 whole square, which is equal 10 pi. After simplification, it gives 0.04. Then further it is equal to 0.4 pi meter per second. In case 3, case C is this y equals 0, that a equal minus 10 pi square into 0, so which is equal to 0. Therefore, at center acceleration is 0 and velocity is then y equal to 0, then acceleration is 0, then v equal to omega, that is 10 pi square root of 0.5 to the square minus 0 square, which is equal to 0.5 pi meter per second. Meter per second. We done for 3 cases here. We have done. Please subscribe our YouTube channel.